This is in standard form. To change it to vertex form, you need to memorize this little formula. After you use this formula, what do you do next? So in this problem, there's a minus from the formula, and the b is 12, and 2 times 3 is 6, and 12 divided by 6 would make this a negative 2. And then you substitute negative 2 squared, and then a negative 2, and then a 7, and when you add all that up, you get a negative 5. So the vertex is negative 2, negative 5. The vertex form looks like this. Where do I get the A? Well, what's the A up here? And the A up here is the same as the A down here. The A is the same no matter what form. And so x minus a minus 2. So that is the vertex form. And what we were working on yesterday was changing from a standard form to vertex form. And now we're going to go back and look at vertex form some more. Does this? No, that color doesn't show up very well. So that was a review problem from yesterday, and so here's example 1 from today's assignment, more vertex form. So what form is that? This is vertex form. And it should be very easy for you to tell me from vertex form, what's the vertex? Positive 2 and 4, because this one will change sign because of the negative in the vertex formula. Can you tell me when I graph this, is it going to open up or open down? How do you know? This starts with a negative, so that means it's going to be opening down. Can you tell me the axis of symmetry? X equals the 2. The axis of symmetry is going to go through the vertex point. Can you tell me whether this vertex point is going to be a maximum or a minimum? Picture might help you out. If it opens down, it's going to be going like this, and the vertex point will be here, so it will be A. And the maximum value is the y value of this point. That's how high up it's going to go. And so the maximum value is going to be at y equals 4. What is the domain and range of this graph? All real numbers. The range is the y value. It's going down, so it's going to be y is less than or equal to the y value of this point. And the final thing from this form is increasing and decreasing. if I start over here on this left-hand side of my graph and trace the graph, my pen is going up. So it is increasing. It is increasing from negative infinity to the vertex point. We put our increasing and decreasing in terms of x. So it's increasing until the x gets to 2. And then what's happening? My pen is going down. And so it is decreasing from 2 to positive infinity. Because the increasing and decreasing is in terms of the x value, and this is 2, 4, and so what is the x value at that point? So the increasing and decreasing has a 2 in it because that's the x value of the vertex, and that's where it changes, is at the vertex. On this side, this is negative infinity, and this side is in positive infinity, because the x-axis as you go this way would be negative infinity, and this way would be positive infinity. It would be a little bit more obvious if we had some graph paper to put our graph on. I am just rewriting this same problem because I had to go over to the next page. And so we're starting out with vertex form. But how do you get it to standard form? Usually, I've been telling my Algebra 1 students, whenever you have a number out in front of the parentheses, you distribute. That's not quite correct, because you cannot distribute the negative 4 into this, because this is squared, and order of operation says you have to do squared first. Now, on the Algebra 1 problems, they don't have anything squared like this. So before I can distribute the negative 4, the first thing I need to do is multiply out this part. I multiply it out with a box problem. And you get x squared minus 4x plus 4. But that's just the parentheses part. A lot of people on the homework problem stopped there. But on this problem, there's a negative 4 in front and a plus 4 in the back. There's a lot of 4's in this problem. Now that this parentheses is not squared, now I can distribute the negative 4. Negative 4 x squared. Negative 4 times negative 4. Negative 4 times the positive 4 plus the 4 at the end. Negative 4x squared plus 16x. And then I need to combine these like terms. And this is standard form. From our standard form, it's easier from the standard form to get the y-intercepts and the x-intercepts. So, do we know the y-intercept? In standard form, the y-intercept is the, it's the c. Was the c a positive 12? The y-intercept is a negative 12. Because this zeroes out and that zeroes out, and the only thing that would be left would be negative 12 if I substituted a 0. So the y-intercept is 0, negative 12. To find the x-intercepts, you let y equal 0 and solve. Well, there's the y. 0 equals negative 4x squared plus 6x minus 12. How do you solve a quadratic? We have 3 methods to solve a quadratic. We can solve it by factoring, we can solve it by the formula, or we can solve it by completing the square. If it will factor, factoring's the easiest way. What do you do first to factor? Am I hearing GCF? And what is the GCF? How about? 4. And I want to use a negative 4 because I don't want to leave a negative in front. And so I'm going to just cancel the whole GCF out. And you multiply the first number times the last number, and you write down the factors of 3. Is there any way those factors of 3 can add up to equal a negative 4? Would that make them add up to equal a negative 4? Would they still multiply together to get me a positive 3? Those are the factors. If this is 1, then I can use my shortcut factoring. What do I have to do if it's not a 1 right here? Factor by grouping. If this was some number other than 1, I would have to factor by grouping. I have not quite finished solving. I have to use my 0 property rule. I need to add 1 to both sides. I need to add 3 to both sides. And these are my solutions. Another name for solutions is roots. Another name for both of those is zeros. In this form, these are solutions or roots or zeros. But I started out to find my x-intercepts. The x-intercepts are written as points. Same number, just written in point form. When you have a homework problem, it asks you to put the smaller x-intercept in first and the larger one in second. That is not mathematically necessary, it's just to help me with the grading, so that everybody puts the problem in the same way. So from our standard form, it's easier to find our y-intercepts and our x-intercepts. From our vertex form, obviously, it's easier to find the vertex. What form is this? And since it's vertex form, you should be able to tell me what the vertex is. From any form, you should be able to tell me whether it opens up or down. The A is what you look at, and the A is the same in every form. So is this going to make it open up or down? This is positive, so it's going to open up. The axis of symmetry is going to go through the vertex point, and so the axis of symmetry is going to be x equals -3. If this graph opens up, is this vertex point a maximum or a minimum. And the minimum value is the y value of this point. That's how far down it goes. The minimum value is -8. What is the domain and range of this graph? All real numbers, it's going up, so y is greater than or equal to -8. Where is it increasing? Where is it decreasing? And to answer the question that was asked previously, this side is -infinity and this side is +infinity. So what does it start doing here on this side? What's it doing? Decreasing. So it's decreasing first from -infinity to the vertex point. We use the x value of the vertex point. That's just traditional to write this in terms of x. And -3 to +infinity would be this side, and it's increasing on this side of the vertex. How do we change it to standard form? Same problem, how do you change it to standard form? Well, the first thing I need to do is multiply out this parentheses. So x squared plus 6x plus 9, that's equal to this parentheses in vertex form, and it has a 2 out in front and a -8 out in back. After you have squared this, then what do you do with the 2 out in front? 2 times 6 is 12. 2 times 9 is 18. Subtract 8. And this is in standard form. Do you understand the difference in distributing here? Here I can distribute. Up here I cannot distribute the 2. I cannot distribute a 2 into a parentheses that is squared, because squared is a higher order of operation than multiplication. Do I have any squareds here? That's why I can distribute here. Once it's in standard form, you should be able to tell me the y-intercept. Once you have it in standard form, you should be able to factor it to find the roots or the x-intercepts. What am I going to do first before I factor? What's the GCF? So 0 equals x squared plus 6x plus 5. Multiply the first number times the last number and write down the factors of 5. Everything's positive, so will those factors add up to equal 6? Since this is 1, I can use my shortcut factoring. This is factored, but it is not solved. I have to finish it by solving it. Subtract 1 from both sides, subtract 5 from both sides. These are the solutions, or roots, or zeros. If I put it in point form, these are the x-intercepts. Can you change from vertex form to standard form to vertex? Can you find the vertex? Can you find the x-intercepts and y-intercepts? Do you know if the graph opens up or down?